this set of notes, we're going to look at correlation analysis. So previously we discussed the coefficient of correlation, or the correlation coefficient, both the same thing, just different names, for the simple linear regression model. So the first thing I'd like you to do is to review this section right here, the coefficient of correlation from simple linear regression. And this is a review from module 3.2. So you're going to read all through this section just as a review. So go ahead and pause the video, and then when you come back, we'll talk about the major correlation coefficient based on the multiple linear regression model. The concept of the correlation coefficient for the simple linear regression model can be extended to the multiple linear regression model. And so just as a reminder, here is the matrix form of the multiple linear regression model. So just as a reminder, when we talk about multiple linear regression, we have our single response variable. We also have our matrix with all of our predictor variables. We have the vector with our coefficients, and then we have the error term. And it ends up for multiple linear regression that there are various correlation coefficients that can be calculated, and each of them are going to tell us something slightly different. And so we're going to look at several of these. The first one is what's called the Pearson's correlation coefficient of zero order. So consider the main effects model with response variable y and predictor variables x1, x2, and x3. The zero order correlation is known as the correlation between the possible pairs of variables. And we can use a matrix to compare these variables to one another, and this matrix is known as the correlation matrix. So let's talk a little bit about the correlation matrix for this example. So one thing, if you'll notice here, is in the diagonal, our diagonal is comprised entirely of ones. And so let's talk about why that is. Notice that our first entry here, what that is looking at is looking at the correlation of y with y. Well, this is going to have a perfect correlation, so that's going to be equal to 1. And so the same thing is true of x1 with x1, x2 with x2, and x3 with x3. Now often with correlation matrix, we write them with only the upper diagonal, and so let's talk about why that is. Let's start out by looking at this element right here. Notice that this element right here is the correlation of y with x1. We could also look at this element right here, and that element right there would correspond to the correlation of x1 with y. But notice that these two are the same thing. It doesn't matter which order we calculate the correlation, we're going to get the same value. And so for this reason, this value and this value are the same. So to make it easier to read, often in a correlation matrix, only the upper diagonal is given. Now software will usually give you both diagonals, but in publications we'll often just include the upper one, again, because that makes it easier to read. Now this was an example where we looked at the correlation matrix where we had a main effects model. Suppose instead we had a quadratic model. So let's say we had that the expected value of y was equal to beta naught plus beta 1 x1 plus beta 2 x1 squared. Well, we could do the same thing and set up a correlation matrix, except what we would be comparing would be y, x1, and x1 squared. And of course along the top we'd have y, x1, x1 squared, and then we could look at our correlation matrix. So this idea isn't only for the main effects model. We can do it when we have functions of variables as predictors. Alright, so let's look at an example. This is an example that we've seen before. Professor Seth Stevens studies the level of racial animus across different areas in America by measuring the percent of Google search queries that include racially charged language. A measurement animus is derived from his algorithm and is scaled between 0 for low racial animus and 250 for high racial animus. So this data set contains observations from 196 different media markets, and we've looked at regression models using this data in the past. For this particular example, we're going to look at a model with 4 independent or predictor variables and with our response equal to animus. So here we could fit the main effects model, and then we could look at the correlation matrix. So here is that correlation matrix. So the first thing that I want to look at is, notice here along the sides we have both our response variable y, which is animus, along with our different predictor variables. And then if you'll notice here along the top, we have the same 5. So notice this is set up just like this matrix that we saw here. The next thing I'd like you to look at is the diagonals. So notice that the diagonal is all equal to 1. And again, this is because if we look at the correlation of a variable with itself, we expect that value to be 1. In other words, for there to be perfect correlation. Next, let's compare the upper and lower diagonal. Compare, for example, the correlation between the percentage of the market that is African American with the animus score. So that would correspond to these two places in the matrix, and notice that they are equal to one another. And so again, this goes back to the idea of why in publications we generally just show the upper portion of the matrix, and again because we know that it's going to be redundant. And we can see this. So for example, if we compared the variable percentage of those who are at least 65 years old living in the media market and the percentage of Hispanics living in the media market, notice that that is going to correspond to this element right here, and that's going to correspond to this element right here, because we've got age 65 plus and Hispanic age 65 plus, and again notice that those values are the same. So taken separately, each of these is going to describe the strength of linear relationship between the two variables involved. So if we look here, for example, if we want to know the correlation between the variables Hispanic and animus, we see that there is a negative correlation. So in other words, what this would suggest is the higher the percentage of Hispanics living in the media market, the lower the animus score. And we see that that is the opposite if we look for Black and animus. The more or the higher the percentage of African Americans living in the media market, we actually expect to see a higher animus score. So here we have a positive correlation, whereas we looked at Hispanic and animus together, we actually end up with a negative correlation. So one thing to note about these zero order correlations is the following. They do not tell us some more complicated relationships that we might be interested in. So for example, they don't tell us the overall relationship of all of the variables together. So for this, we need what's called the multiple correlation coefficient and the relationship between two of the variables when accounting for the others. For this, we would need what's called the partial correlation coefficient, and we're going to cover each of these in the next set of notes.